Hello all. Today we will discuss the interference due to thin film of uniform thickness. Here we have a thin film of thickness of D immersed in air medium which has a refractive index of mu. Okay, light is falling from the top surface of thin film. A ray is falling falling on the top surface of thin film and gets reflected from the top surface, and there will be a refraction through the medium, thin film medium, and again at this point there will be a reflection to the medium itself and refraction to the air medium. Again at this point there will be a refraction and reflection. So there are multiple reflection and refraction will happen. Now this is an example of interference due to amplitude division. Since at each reflection and refraction the amplitude of incident light is getting decreased. Okay, now when we focus these reflected rays on the top surface of thin film with the help of convex lens at the point P, we can see interference pattern. For the ease of convenience, we are going to consider only two rays that are coming from the point A and C. Okay, now if we consider these two rays here, means I am going to draw three normal lines that are perpendicular to the thin film surface, that is this one and this one and another line, this one, and we know this is angle of incident, that must be equal to angle of reflection, and here this is my angle of refraction, or and here these two lines are parallel lines and this angle is now adjacent angle. We know adjacent angles are equal. If this is R, this also must be equal to R due to law of reflection. And again, if so, these two angles here are corresponding angle, and if this is I and this also has to be I, if this is I, this angle also has to be I. And we can see, since this line, this I'm going to draw a normal line to AD from the point C, so it's a normal, so it has 90 degree here, and so if this is 90, this also has to be 90, but we have I angle here, so this must be 90 minus I, so this is 90 and here we have 90 minus I, so if so this angle must be equal to I. So if we add all these three angle, we will get 180 degree. Okay, now if you see these two rays, ray 1 and 2, when they focus at this point, if we consider they are coming from this point D and C, there won't be any path difference between these two rays. Okay, so the path difference comes due to the path length difference of rays only up to this much. Okay, means if we consider this is ray 1 and this is your ray 2, we see ray 2 traveled extra distance into the medium and ray 1 is traveled up to this much, so it ray 2 covered extra distance, so the path length difference, the difference in the path length of ray 1 and ray 2 can be expressed by this formula, where delta L represent the path difference and mu is the refractive index AB plus BC. So AB plus BC minus AD. Why this AB and BC are multiplied with mu? So it is due to the changes in refractive index. So ray 1 is moving only in the air medium, whereas ray 2 is moving in thin film medium whose refractive index is mu. So when we know that when light moves in a denser medium, it will be slowed down. So to account that, we multiply this length by mu to calculate the actual path difference. Okay, now since these two triangle AB and I and IB IBC are concurrent triangles, this side AB should be equal to BC. So this ABBC can be written as 2 times AB, and this is my equation number 1. And so how to represent? Now I have to calculate AB and AD. So I'm going to find AB with the help of cosine of refractive index, means refractive angle of refraction, cosine of angle of refraction, and that is equal to, so adjacent side by hypotenuse. Adjacent side is BI and hypotenuse is AB. So what is BI? BI, we know it is T, thickness of thin film. So AB can be written as T by cosine of R. Now how to find AD? AD is sin AD. We can find this path length of first ray. AD is equal to uh, sine of incident angle, which is AD by AC. AD by AC. We know AC is nothing but AI plus IC. AI plus IC, and also this AI is equal to IC. I am going to write it as 2 times AI. So from here we can find AD. AD is equal to 2 times AI into sin I. So now I am going to substitute here. So again I have to find tan R, means AI. To find AI, I am going to find tan of R, which is AI by BI. AI by BI, we know BI is T, so AI is T times tan R, and so AD, substituting this AI here, we get AD is equal to 2T tan R into sin I. So this is my equation number 4. So what is now? Substitute equation 2, 3, 4 into equation number 1. We get equation number 5, which is 2 mu t. So substitute AB is here and AD is here. So 2 mu t cos R minus 2t tan R into sin R. So we can, using law of refraction, we can write sin I by sin R is equal to mu. Sin I is equal to mu times sin R, and substituting that we get delta L in the following form: 2 mu t by cos R minus 2t sin R by cos R mu times sin R, and we get delta L is equal to 2 mu t cos R into 1 minus sin squared I. So sin squared I can be written as cos squared I, and cos R into cos squared R can be simplified with this following way: delta is equal to 2 mu t cos R. Here I have subtracted an extra factor from delta L, that is due to, since the first ray, means the ray 1 is getting reflected from the denser medium, there will be a phase change of pi that corresponds to the path difference of path length of lambda by 2. That's why this lambda by 2 is subtracted from the actual path length. So we get delta L is equal to 2 mu t cos R minus delta by 2. So now this is the path length difference between the two rays that are going to point P, means to the screen. Now what is the condition for maxima? So the condition for maxima is delta L should be equal to n times the lambda, integral multiple of lambda. If the path difference is n lambda, we get the maxima, that is constructive interference, and 2 mu t cos R minus lambda by 2 is equal to n lambda. So 2 mu t cos R is equal to 2n plus 1 lambda by 2. This is the condition for maxima. Now what is the condition for minima? Delta L should be equal to 2m plus 1 lambda by 2, and if you simplify, you get 2 mu t cos R is equal to m lambda. That's all. Thank you.